Hey guys, my name is Nathaniel McLean and welcome back to Conquering Chem. In the last video, we talked about matter and its properties and its classifications as well. In this video, we'll be talking about SI units, and in the following video, we'll be talking about density and percent composition. I'll leave the links to all of those videos in the description in case you need to skip around for any topic that you're interested in at this time. Now moving on with SI units. When we look at the SI units, this big fancy word system, international, d'unités, not important. What's important is that you know what SI units are. And the SI units are basically a way of scientists and people alike to be able to relate data to each other so that it is easier to interpret, easier to translate, easier to scale, and just easier in general to do anything. It's a universal type of language for people doing any type of science. And so when we look at SI units, there are 7 base units: length, mass, time, temperature, the amount of substance or the mole, the electric current, and the luminous intensity. The first 5 SI-based units are what we'll be mainly concerned with for general chemistry, the length all the way to the mole. And these are the unit symbols for the base units. As you can see here, M for meter, S for seconds, kg for kilogram, mole for mole, and so on. This right here is to just show you how SI units are translated on a power scale using the base of 10. So as we'll see in further examples, we can move from one SI unit measurement to another by using the correct conversion factor here. So as we move on to some examples of using SI units, let's say we want to convert 1,000 meters to kilometers and then to centimeters. We can easily go back here and look at the conversion factors. Now we see that the kilometer is 10 to the power 3 and our base unit is 10 to the power 0. So we can easily put that 10 to the power 3 into our calculation to find the amount of meters, the amount of kilometers, and the amount of centimeters. So if we want to move from 10 meters to kilometers, we would simply divide by 10 to the power 3. Now if we want to move from 1,000 meters to centimeters, we can simply multiply that by 10 to the power 2. As can be seen here, centi is 10 to the power minus 2. But of course, if we're moving from one to the next, you have to consider how big or how small the quantity is moving. Another example, let's say we wanted to convert 0.457 kilograms to grams and then to milligrams, only using the conversion factors seen in the table in the previous slide. That 0.457 kilograms, we would multiply that by 10 to the power 3 to convert that to grams. As you can see here, the kilogram would be 10 to the power 3, so we multiply that. However, if we're moving from kilograms to milligrams, instead of 10 to the power 3, we see that there is a space of 6 units between the kilogram and the milligram. So 10 to the power 3, and you can simply add the absolute value of 10 to the power minus 3, which is another 10 to the power 3, to give you 10 to the power 6, or 0.457 times 10 to the 6, giving us 457,000 milligrams. Moving on to some of the definitions of the SI units which we'll be using for this general chemistry course. We have the mass, which is the quantity of matter in an object. Now the SI unit for mass is actually the kilogram, even though you will mainly see grams more so than kilogram, so just don't let that confuse you. We have time, which is the indefinite continued progress of existence. The SI unit for that is the second, or the symbol S. And then we have temperature, which is a reference to measure of the warmth or coldness of an object. And the SI unit for that is Kelvin. Similar to mass, you might see Celsius or Fahrenheit more so than Kelvin, but always remember that the SI unit is actually the Kelvin. And for the sake of facilitating that, I have the conversion factors here to move from Fahrenheit to Celsius and from Celsius to Kelvin and all the in-between to help you. So looking at an example, if we want to move from 57 degrees Fahrenheit to Celsius, we follow the equation on the left, 5 divided by 9 times the Fahrenheit minus 32, which would give us 13.89 degrees Celsius. Now, moving from Celsius to Kelvin is actually much easier, because if you have a degree in Celsius, you can easily add 273.15. So remember that number for your calculations, 273.15. As you can see here, this is an extended equation, which moves from Fahrenheit to Kelvin. But if you break this equation down, the first part is converting Fahrenheit to Celsius, and the second part, Celsius to Kelvin, giving us that 287.039 Kelvin. Within the SI units, you would also find derived units from those SI units, and derived units are simply a combination of the base units. So for example, if we wanted to find the area, we would have to multiply a length times a length to make it into a two-dimensional shape. When we look at the different properties of those measurements, we can have an intensive property or an extensive property. And in the next slide, we'll look at density, which is an intensive property. And all that means is that no matter what happens, this property will stay the same given an object. So for example, the density of water, if you pick up a glass of water, the density is going to be approximately 1 gram per centimeter cube. That is not going to change whether it's a cup of water or whether it's a whole pool of water. Extensive properties, however, depend on the amount of substance available. So volume, mass, that sort of stuff is what would be called an extensive property. And then moving on, I just wanted to include a few non-SI unit conversions for you in case any questions were to ask for you to convert them. I will do one example and then I'll do more examples in the tutorial sessions. So we'll look at this a little bit later. An example of the conversion factor, or what some of your professors might introduce as dimensional analysis, it is simply the proper way of moving from one measurement to a next or to do calculations. So if we go here, we see that we want to convert 1.87 meters to centimeters. So usually we would just multiply by 100 based on what we know in our head. But to do this by dimensional analysis, we would place the 1.87 meters in the numerator and then multiply by the conversion factor, which would be 100 centimeters divided by 1 meter, so that the m's cancel out or factor out, and leaving us with the centimeters only and the answer that we need. Now, a more complex example would be if we wanted to move from 11 meters squared to feet squared, given a limited set of information, such as that 1 meter is equal to 3.28 feet. Knowing that we're moving from a square quantity to another square quantity, we want to make sure that our feet are squared as well. So again, just like the original example, we place the measurement we're trying to convert, and then we enter the conversion factor, which would be 3.28 feet. And since we square that, it will be multiplied by another 3.28 feet, both of them over 1 meter, because there is 3.28 feet in 1 meter, giving us our final answer in square feet, a value of 118.34. And this was a quick video, just wanted to give you some examples of SI units, introduce them to you, and make it easier for the sections that follow. In the next section, we'll be talking about density and percent composition, so stay tuned for that video. Feel free to go back to the previous video if you need another recap or rewatch this as necessary. Thank you again for watching. I appreciate your time and I hope that it was some help. If you liked the video, please like, share, comment, and subscribe, and look forward to all the information that I will be putting on my YouTube page as well as my Patreon. Thank you and see you in the next video.